All right, we're back with problem number 7 from your chapter 9 and 10 practice test, where we are going to describe the graph of the system as two intersecting lines, two parallel non-intersecting lines, that's what makes them parallel, or coincident lines, and coincident lines means they're exactly the same line. So we have two equations, 12x minus 6y equals 16, and 60x minus 30y equals 11. I'm going to just solve the system. I'm going to kind of ignore the fact that we're deciding or describing the lines at the moment. I'm just going to take this system and I'm going to solve it. I'm going to find out what x and y has to be in each of these to make both of these equations true. So if I look at this, I can't use substitution because I don't have y equals anything and I don't have x equals anything. I don't have either one of those variables isolated. So I'm just going to kind of manipulate these things and use addition and multiplication. And the reason why is because I notice that our x terms are lined up, our y terms are lined up, our equal signs are lined up, and then our constant terms are lined up. So if I add these together as they stand right now, none of the variables are going to go away. The x's will not go away because these won't cancel out. These won't cancel out either because negative 6 and negative 30 aren't opposites. So those aren't going to cancel out. So I have to manipulate one of these things. And ideally, what I'm seeing is that I want this negative 6 right here to be a positive 30. That's what I want this to be. I want this to be a positive 30 because if this is a positive 30, then when I add these two equations together, the y's will cancel out. Or you could look at it and say, I want this 12 to be a negative 60, depending upon which variable you want to go away. But for me, it's easier to see, well, I know that negative 6 times negative 5 will give me a positive 30, and then the y's will cancel out. So what I'm going to do is this. I'm going to take the top equation and I'm going to multiply it by negative 5. And I choose negative 5 because when I do negative 5 times negative 6, I'm going to get a positive 30, and then our y's will cancel out. So when I multiply the top equation by negative 5, what I'm going to get is this equation. Negative 60x comes from negative 5 times 12x. Negative 5 times 12x is negative 60x. Negative 5 times negative 6y is positive 30y, and negative 5 times 16 is negative 80. So the top equation has become this equation by multiplying it by 5. Bottom equation stays the same. I didn't change it. Now when I take these two equations and add them together, our y's are going to cancel out because we have a positive 30y and a negative 30y. So I'm going to add these equations together, add everything together. So we have negative 60x and a positive 60x, well, that's 0. And then our 30 and our negative 30 y's cancel out, and then negative 80 and a positive 11 gives us negative 69. So now what we have here really is 0 plus 0 equals 69. Well, that's like saying 0 equals negative 69. That doesn't make any sense. 0 equals negative 69. Both our variables just went away. I tried to get rid of y, but it turns out I got rid of x too. And now I'm left with 0 equals negative 69. So what this means, this statement's false. So solving the system results in a false statement. 0 does not equal negative 69. So therefore, there's no solution to this system. And if I was to graph these lines, the two lines would be parallel. They would not intersect. They would have no point in common. These two equations have no point in common because they are parallel.